Welcome to MRL. In this learning session, we'll be learning about exponential notation. Now, what is exponential notation? Exponential notation is a method of representing repeated multiplication. What does that mean? So, let us say we have 2 multiplied 6 times. That means 2 is multiplied 6 times here. Instead of saying that 2 is multiplied 6 times, that is repeated multiplication of 2 6 times, we can write it as 2 raised to 6. Now 2 raised to 6 is the exponential form of 2 having been multiplied 6 times. So the repeated multiplication of 2 with itself 6 times is written in exponential notation form as 2 raised to 6. In this, 2 is called as the base and 6 is called as the exponent or power or index. Therefore, remember, in an exponential notation there are 2 parts. 2 is the base and 6 is the exponent, and it is read as 2 raised to the power 6. Please remember, 2 raised to 6 is read as 2 raised to the power 6 or 2 to the power of 6. Now the generalization of this would be, if a is multiplied n times, then we can write it as a raised to n, where a is the base, n is the exponent, and it is read as a raised to the power n or a raised to n. So please remember that. Now we have an example here. 3 is multiplied 4 times. So therefore the exponential notation will be 3 raised to 4. The base is 3, the power is 4, or the exponent is 4. But also if you pair the 3's here, we have 3 into 3 is 9, 3 into 3 is 9, that is 9 into 9 is 9 square. So we have 9 square. So 3 square raised to 2. That means one pair of 3, another pair of 3 becomes 3 square and 3 square, and raised to 2 becomes 9 square. Here the base is 9 and the power is 2. That means 81, which is 81 can be written as 3 raised to 4, or 81 also can be written as 9 raised to 2. That means the same number 81 can be expressed with different bases and different powers. That is what we have to remember. Same number can be written with different bases and exponents. So 81 is written as 3 raised to 4 here, base is 3, power is 4. 81 is again is written with base 9 and power 2. Remember that. Exponential form and the expanded form. 10 raised to 3 is exponential form, and 10 into 10 into 10 is the expanded form. Here 10 raised to 3 means 10 is multiplied 3 times, and this is the expanded form of 10 raised to 3, or this is the exponential form of 10 into 10 into 10. So we have to know to write the exponential form as well as the expanded form of any given number. Now 1 by 1000. 1 by 1000 can be written as 1 by 10 into 1 by 10 into 1 by 10, which is 1 by 1000. That means 1 by 10 is multiplied 3 times here, and that can be written in the exponential form as 1 by 10 raised to 3. Similarly, 1 by 1024, it means that 1 by 2 into 1 by 2 into 1 by 2 is multiplied 10 times, and which can be written as 1 by 2 raised to 10. So therefore, we can convert any number in exponential form in this method. Now here 1024 is 2 into 2 into 2 is multiplied 10 times, and therefore the exponential form is 2 raised to 10. And to find the exponential form, just divide 1024 by its prime numbers or prime factors. We get this here. We have divided 1024 by 2. We have got 10 2's here, and that is the exponential form of about 1024, which is 10 raised to 2. Remember that. Now the laws of exponents are very important for us to understand, and very useful in calculation exponential forms. Now the first important law is a raised to m into a raised to n is equal to a raised to m plus n. So please again let me repeat, a raised to m, that means a is multiplied m times here, again a is multiplied n times here. When we take the product, then it is the same as a raised to m plus n, rather a is multiplied m plus n times. Now let us take one example and understand it. If I find out 2 raised to 10, that is 2 is multiplied 10 times, I get 1024. But I get 1024 by multiplying 16 and 64 also. But 16 is 2 raised to 4. That means when I multiply 2 4 times I get 16. When I multiplied 2 6 times I get 64. If I take the product I get 1024. That means 2 raised to 4 into 2 raised to 6 is 2 raised to 10. That means, but here that means 2 raised to 10 is equal to 2 raised to 4 plus 6, and that is 1024. Whether I take 2 raised to 10, it is 1024. But if I find 2 raised to 4 and multiply by 2 raised to 6, I get 1024. Or rather 2 raised to 4 plus 6 times is also 1024. Therefore we can conclude that a raised to m into a raised to n is equal to a raised to m plus n. That means a multiplied m times, again a multiplied n times, taking that product is nothing but is equal to a raised to m plus n. Rather a is multiplied m plus n times. Remember this, a very important law and useful for calculations. Now the second law states that a raised to m divided by a raised to n. Again I'll repeat, a raised to m divided by a raised to n. That means a is multiplied m times here. When divided by a multiplied n times, we get a raised to m minus n. Rather it is nothing but multiplication of a m minus n times. But here m is greater than n. Now to understand this, 2 raised to 6. 2 raised to 6 is 64. When I multiply 2 by 2 6 times I get 64. And also when I multiply 2 10 times I get 1024. I multiply 2 4 times I get 16. When I divide 1024 by 16 I get 64. That means what I have done here is I have divided 2 raised to 10 by 2 raised to 4. 10 minus 4 is also 6. That means again we get 2 raised to 6. 2 raised to 6 is equal to 64. What it implies is that 2 raised to 10 divided by 2 raised to 4 is nothing but 2 raised to 10 minus 4, which is 2 raised to 6 and 64. So whether I take 2 raised to 6 is equal to 64, that means it makes us clear that a raised to m divided by a raised to n is a raised to m minus n when m is greater than n. If m is less than n, it will be 1 divided by a raised to n minus m, which is important for us to remember. Now the third law, a raised to m raised to n is equal to a raised to mn. Now what does this mean? That means here a raised to m is multiplied n number of times, and the value is nothing but a when multiplied mn times. A is multiplied mn times. Now let us take one example here for understanding. 3 raised to 12 is equal to 3 raised to 6 plus 6. That means 3 is multiplied 6 times, and again 3 is multiplied 6 times. When we take the product, the value is 3 raised to 12. So the value of 3 raised to 12 or 3 raised to 6 multiplication of 3 raised to 6 is the same. That means 3 raised to 6 into 3 raised to 6 is nothing but 3 raised to 6 is multiplied 2 times. Therefore 3 raised to 6 to the power of 2, and 6 into 2 is 12, and that is 3 raised to 12. So whether I multiply 3 raised to 6 2 times or 3 raised to 6 into 2 or 3 raised to 12, the value is the same, and therefore a raised to m raised to n is equal to a mn. That means a raised to m here, 3 raised to m or 3 raised to 6 into 2 is 3 raised to 12. So also instead of 3 we have taken a here, instead of 6 I have taken m here, instead of 2 I have taken n here. So a raised to mn, a raised to m raised to n is equal to a mn. The meaning of this is that when we multiply a raised to m n times is the same as multiplying a mn times. So that is what is the law, and a very important law for us to remember. Now the next important law is a into b raised to m is equal to a raised to m into b raised to m. That means the product raised to any power is equal to the product of the powers of the individual numbers. That means if I have 10 raised to 4, 10 raised to 4 is 10 into 10 into 10. The prime factors are 2 into 5, 2 into 5, 2 into 5. That means 2 is multiplied 4 times, 5 is multiplied 4 times. That means 2 multiplied 4 times is 2 raised to 4, 5 times is 5 raised to 4, and 5 is multiplied 4 times, therefore it is 5 raised to 4. Then 2 raised to 4 into 5 raised to 4 is 2 into 5 raised to 4. 2 into 5 raised to 4 is nothing but 10, and that is 10 raised to 4. So that means expressing 10 raised to 4 as 2 into 5 and raised to 4 is the same as 2 raised to 4 into 5 raised to 4. Therefore the law is very much proved here. That means a into b raised to m is equal to a raised to m into b raised to m. That means multiply a into b and raise it to power, we get the same value, or multiply a m times and then multiply by b multiplied by m times, the answer is the same, and therefore a into b raised to m is equal to a raised to m into b raised to m. A very important law to remember. Now the very next important law is a by b raised to m is equal to a raised to m by b raised to m. Let us take an example to understand or prove this law. 3 by 4 is to 5. The expanded form of this will be 3 by 4 has to be multiplied 5 times. So 3 by 4 into 3 by 4 5 times. So now when I take the product, then I have to take the product of the numerator and the product of the denominator. The product of the numerator is 3 into 3 3, that is 5 times. 4 into 4 into 5 times. Therefore it is 3 raised to 5 4 raised to 5. That means 3 by 4 raised to 5, the value is the same as 3 raised to 5 divided by 4 raised to 5, which concludes that a by b raised to m is a raised to m by b raised to m. So please remember that. Now the next law is 2 raised to 5 divided by 2 raised to 5. Let us understand this. 2 raised to 5 divided by 2 raised to 5 is equal to 1. You know that the numerator and the denominator are the same. When we divide, we get the value 1. Now 2 raised to 5 divided by 2 raised to 5 can be written as 2 raised to 5 minus 5, because using the law that a raised to m by a raised to n is equal to a raised to m minus n. Therefore 2 raised to 5 divided by 2 raised to 5, here a is 2, m is 5, n is 5, 2 raised to, that is a is m minus n. So 2 raised to 5 minus 5 becomes 2 raised to 0, and 2 raised to 0 is 1, because 2 raised to 5 by 2 raised to 5 is 1. Therefore the LHS 2 raised to 5 by 2 raised to 5 is 1, and 2 raised to 0 therefore has to be 1. If you have to generalize it, instead of 2, let me take it as a. Therefore any number raised to 0 is always 1. Remember that. The next law, that is a raised to minus n is equal to 1 by a raised to n, or 1 by a raised to n is equal to a raised to minus n. Let us take an example here. 1 by 32. 1 by 32 can be written as 2 by 64, and 2 by 64 is 2 raised to 1 upon 2 raised to 6, and we can apply the law that a raised to m by a raised to n is equal to 1 by a raised to n minus m, because n is greater than m here, and therefore we get 1 divided by 2 raised to 6 minus 1, and that is 1 by 2 raised to 5. That means 1 by 32 is 1 by 2 raised to 5. Now 1 by 32 also can be written as 2 by 64, which is 2 raised to 1 by 2 raised to 6. We can apply the law a raised to m by a raised to n is equal to a raised to what we call m minus n, that is 2 raised to 1 minus 6. 2 raised to 1 minus 6 is greater here, that is minus 6, 1 minus 6 is minus 5, so 2 raised to minus 5. That means 1 by 32 is 1 by 2 raised to 5, or 1 by 32 is 2 raised to minus 5. That means 2 raised to minus 5 is equal to 1 by 2 raised to 5. That means a raised to minus n is equal to 1 by a raised to n, or 1 by a raised to n is equal to what? A raised to minus n. That is what you have to remember.